Thank you for coming. This is not or normally when I do a talk, do I find I have to be fighting my way into my own talk. But the corridors were so packed. Normally I'm here and waiting for you guys to turn up. So it was refreshing to have to fight in. I'm just going to take a photo. Say cheese. Thank you. That's for two reasons. One is to prove to my boss that I'm not just here drinking wine. And the second thing is I may remember to take it later to see whether or not you're any more frightened than you are now. Right, so this talk is a whirlwind talk through this topic, the anatomy of Java, and I hope that when it's finished you leave here slightly better informed, but a lot more worried. Okay, this is, I hope I burst your bubble a little bit, and that you leave this conference going, that was the best conference ever, but now I'm really depressed. Okay, and you will see why. Okay, so this is me. Let me start my timer. So I work for IBM. I've done Java virtual machine development for a long time. I always say since before it was 0.9 something. And I did that for a long time, and then I took basically a sabbatical for 2 or 3 years, and I led a big DevOps team. And it's the experiences in that I learned about the situation with security and things like that, and that I brought back when I came back to the Java team and went, we need to tell Java developers about things. And that's what this talk is about, right? So it's about Java vulnerabilities. So I'm going to cover in this talk some boring things like how we manage vulnerabilities and things like what are attack vectors, so that you can start to get some of the terminology. The scary things, because there are some really big scary things here, and okay, it looks quite weird from this side. Why you should care. You're a developer. What has security got to do to you? For your see. And of course, code. It wouldn't be any good if we didn't put code up. So we're going to have some code and etc. So I'm going to start with what is a vulnerability? How many people have heard of the word vulnerability? Yes. How many of you know what they are? Oh, cool, good. No, I was hoping a lot more. Okay, so let's start with some code. Java vulnerability. Really? Okay, so this is a GitHub diff. It's in some code that does parsing of doubles. And you can see the minus and plus, and you can see it's just 2-character change. That 2-character change solved a very large problem. So let me talk about it. For some time, it was known, can you see that red against? I hope that's okay, because I've got red on black. So it was known that there was this bug. It had been reported in 2001, and it was in parse double. And if you gave parse double a string with that number, which you can hardly see in it, because we didn't have that fix, the parsing routine would just loop, and basically your thread would hang. And we went, so what? It's just one of those things, right? Really obscure. Who's ever going to come up with, well, there's not just that number, but that's, there was a variation of it, okay? But it turned out not to be a corner case at all, because somebody figured out how to get that number into some data they could send to your website, okay? And if we, as Java engineers, took the string in and just fed it into parse double, what would happen? We would hang. And here's the really horrible thing. Where would you find floating point numbers that get parsed? You might go, well, that's unusual. Can't be that bad. Well, it turns out to be something really straightforward. So you can go read about all the HTTP headers that can be sent to your server, and there's a URL and you go read them. One of them is called accept, which you may know about, which is where the client tells the server what he's interested in, okay? And in the BNF spec for accept, you can see all the wordage, but there's one that says one of the things takes a float. So what could happen would be that somebody would say, as an example, it's not the only way, somebody would say, I will accept some content from the server, in this case that's of audio type, and then you see the Q equals. Well, Q is part of the spec, right? It's part of the negotiation. It's a float. So people did this, stuck the number in, right? And of course, they just did things like this. Curl, blah, to your server. If you were running Java and you had that bug, and they did this to your server, your thread would hang. And they do it again and again and again and again and again until your system stopped, right? And you can read all about this in detail, the URL, and I'll put the slides up afterwards, but there's the URL. Basically, incredibly easy to exploit. That's the big word to remember. Lots of curious people. The canonical hacker, the 15-year-old in his bedroom, go on, I can do that. I know Unix, I know Linux, curl blah, right? You can imagine the consequences to us, to those of us who provided any sort of JVM. All JVMs had to be fixed, and of course all the app servers had to take the fixes, etc., right? Cost enormous amount of money. So there's the first one. So the first thing we're going to put on the list in terms of what a vulnerability is it's a bug with an exploit. Somebody figured out how to make use of that bug to do something bad. Okay. So exploit is the word to think about, and exploits do all sorts of interesting things. I'm sure you put 5 minutes thinking about it, you'll come up with the same list. Basically, they can bring your server down because they can do denial of service attacks on you. Right? They can make it crash, they can make it hang, they can steal your data, they can modify your data, they can run code. Okay, and we'll talk about how they do that. And of course, breaching confidentiality, they can get in there. They can find ways to raise their access, okay? That's all the things bad guys can do this, right? That's just the taxonomy. And we can add in a new one, which is coming along, which is people steal your CPU time because they can do Bitcoin mining. Just an example, if you're connecting to a Wi-Fi, like now, you might have gone through some sort of what's called constraint portal where you're negotiating, you're saying, I accept conditions. At that point, you're running JavaScript. So this isn't a Java story, but it's an example. That JavaScript, there are examples of people running Bitcoin mining while you're waiting, while you're deciding whether you're going to accept it or not. They stole your CPU, right? So they can steal your CPU on the servers that you run your applications on, okay? It all starts to sound a bit horrible. So, why should you care? Well, as a developer, you might go, not my problem, okay? And you might go, it's all to do with somebody else, it's all to do with ops teams. And there may be some truth in that, but developers have their own responsibilities, which we'll get to. So before I do that, I want to talk about the scale of the problem, just how big this is, so that you get level set. We all tend to ignore this stuff. We read about it, but we don't put any context around it. So I'm going to talk about this thing, cybercrime realities. So this is non-technical, but it's important for you to understand. So there are some assumptions about developers that people make. And they think that cybercrime is done by people who sit at home in their bedroom, you know, 500 pounds, and they hack everything. And you go, no. What you have to remember is cybercrime is very, very organized. And the people hacking our systems are as educated as us. In fact, you can go to any developer conference and you can expect that a few of the people sitting next to you, or at least in the conference, will be learning about your systems just the way that you're learning about Spring. They'll be thinking, how do I exploit that? Right? Because that's what they do. They're very motivated. Right? In 2016, cybercrime, that's actually a picture of a man in a hoodie, $450 billion. The drug trade at the same time, right? Heroin, cocaine, all that sort of stuff, $435 billion. 2016, cybercrime was worth more than the whole of the drug trade. Okay, that's how serious. You think of all the movies you've seen about drug trade, the violence, the money. Well, there we go. And then which of these do you think has the least risk? If you are, what's going to get you killed? Hacking somebody's system or running a drug den? Well, yeah, okay. Which one is least likely to get, you're going to get caught? It turns out that being caught for cybercrime, it's almost impossible. You are, unless you're really stupid, it's something that they find out. You're found out because you do something else wrong, and then they just discover that you had a computer or you're part of a gang doing this stuff, okay? So, which is growing the fastest? Which is hardest to prosecute? Which one is going to be reaching $2,100 billion by the end of next year? Which one is going to reach $6,000 billion by 2021? Okay, you can guess. So let me put that in context for you. Here's a little graph. So the red line, cybercrime, the one we care about. The green one, the drug trade. These are the predictions. And some of this is real data, of course. Ooh. The drug trade is static-ish, right? That's about, I think it's about 1 or 2% of the world's national product, that line, that green one. Think what that red one is, right? If you do the maths and you work out how many people are on the planet, 600 euros each. That's how much they're going to take from you every year for everybody in this room, everybody on the planet. That's how much it's worth. That's why this is a serious problem, and this is why I hope your reason here is to learn a little bit about what you can do. So this talk isn't so much about how to fix this, that we'll talk about at the end. It's just trying to get your head in the right place and start thinking about what vulnerabilities are, right? So I'm going to do another one. Let's do some more code. I have this URL. You can tell I've got a Mac, /users foo spacebar. And I want to refer to it in a URL, okay? So there we are, file, colon, blah, blah, blah. And I've got %20 because that's how you encode it. So there we are, nice little URL, okay? And then I write some code around that, so I want to be able to print it out and check if it exists. So I've got my string, I create a file from the URL, and I print out two things. One is, get me the absolute path, and the other thing is, does it exist? They're my two checks, they're my two bits of code. So I run that. First one says, there's the path as expected. The second one says, false. Okay, that's a problem because I thought I'd created the file. So what's the problem? I forgot to decode it. I was so excited. So what you do, if you're writing Java code, is you might add a couple of lines in like this, where you add in a URI, because that'll do the decoding for you. So it'll turn the %20s back into spaces, etc. So yeah, slightly different code. Now I've got a path with the space in, so the system will say that exists, because obviously %20 was a different path. So it's true, okay. So what happened there was I got the name slightly wrong, and the system said, doesn't exist, and that's great. What would happen if somebody had got onto my system and had actually created that file? Because it's a valid file name, right? If I'd run that code again, without those changes, the first set, it would have passed. Okay? Not a big deal? Okay. It is a big deal because on Windows, the root directory, anybody can create files, right? It's designed that way. So I can make directory something at the top of the root. Okay, so I have the ability, if I get onto your system, to create files, right? And you may go, don't understand, how is this a problem? So what happens if, instead of this being a random file, it was a path on your class path, your extensions directory, one of those things, right? It's quite often, when you look at systems, especially complicated systems, that they have class paths of all the various paths in Java, and some of them don't exist. So what happens if somebody says, well, you've got this thing on your system which you don't know exists. What happens if I create it? right? What happens if the file, that path that didn't exist, I get into your system, I create it, so that when you run your code the next time, you're now going to go through a path, a search path. Now one of those entries exists where it didn't exist before. So when that happens, I can run code. Because if I can get code into your system, or you've got code in your system that I can subvert, I can get into your system because I let you, or you got into my system, you created a missing path. Something that didn't work before now works, okay? And that's all because of something like this, right? It's just one line of code, right? And the thing is, it's almost a true story. That sort of vulnerability, there was something similar like that in the VM, where we weren't decoding the path correctly. So we will have, it means that you have the opportunity for the path to be represented in sort of two manners, right? And that was a vulnerability. A really simple one-line bug gave a weakness, and somebody figured it out and exploited it, okay? So I would say the first thing you have to remember about this is vulnerabilities are almost always really simple bits of code, right? They're not big things saying this is a vulnerability. People don't have lots of comments saying we must fix this. You know, it's not like that. It's the fact that they're really simple, but people find them and join them together to exploit them. So any individual thing that you see, apart from like the ones we did at the beginning, where it's a really big problem, the little ones get joined together to become an exploit, okay? Now, I need to say, before we go any further, that it's not just the tech that they're after. They're not looking just at your code, but we will look at that. They do something else. They do what's called social engineering. They're after people because, right, if they can manipulate us, that's easier, even easier than manipulating code, okay? And there's a whole type of set of people that they traditionally go for, right, which I won't go into any details. You can see some of the comments there. But they go for developers. Why do they go for developers? Because we are ignorant, right? We know the inside story. We write the code. We have elevated privileges. We use root. We are over-trusting. How many people here have ever downloaded something from the internet? Okay. How many of you have ever checked the license of the thing that you've downloaded? Okay, right. How many of you ever checked to see whether the person that's giving you the thing is probably trustworthy or not? Okay, look, some of you, excellent. Generally, we're very good at going, I have a problem, go on to Google, you go on to Slashdot or whatever, and somebody says, hey, we use this product or this open source component. And you go to Maven and you stick it into your POM, and the next thing you know, you've got some code, right? But we don't check anything about what it does or what the provenance is. You know, maybe we don't even check the license, okay? We just do it. We just take it because we trust these people. And we don't understand the bad things that can happen by doing so, okay? As it says, the bad guys, they prey on the weak, the vulnerable and the ignorant, which is us, okay? And if you don't agree, let's just do some examples. How many people have done this? How many of you ever Googled for any of these? Getting Java to accept all the certificates over HTTPS. Yeah, I've done that one. How to trust an Ssl certificate. Very trusting trust manager. Disable certificate validation in Java or any tool. How do I turn off curl SSL checking? We all do it, right? How about this? Anybody written one of these? Oh, trust manager. Yeah. And there are the two things important bit. Is client trusted? Is server trusted? Return true. Of course it's trusted. I wrote the code. Okay? We all do this all the time. Okay? So how bad can it be that we do these things? Well, I did a Google search. I said, let's search for implements, Google GitHub search, implements trust manager. Okay. How many people think that I found something on GitHub? Really? Everybody. Okay. Right, so what was the answer? This is 100,000 hits. And I pulled out some of the words. What can I say? A very friendly, accepting trust manager factory allows anything through. People are sharing this code. A very trusting trust manager that accepts anything, etc., etc. Okay, so here's the scary bit. This is on GitHub. So two things are happening. One is it's available for us to use, and second, the bad guys can find it too. So they Google for this, they go to GitHub, they find these things, and they track it, and they find out that it's in your favorite thing that you just downloaded. Because the guys who wrote the code of the stuff that you're using didn't know better and said, oh, it's just a problem. Well, let's have our own trust manager that trusts everything, because it won't be a problem. Okay? And they put it in, and it's got a feature. So to my list, I'm going to add bug, feature. Right? Think about that. Things that we created for our own benefit or for our product benefit gets exploited. Okay? People are looking for this stuff all the time. I cannot emphasize how much of an arms race is going on with the guys who are wearing the white hats and the black hats looking all the time for these vulnerabilities. Scanning code, reading, using their brains differently to look at your API definitions, all the stuff, and going, oh, I think I can see a vulnerability there, right? Okay, so I'm going to calm down, and now we're going to just do the boring bits so that you understand what happens, and I will whiz through this. So we're going to do the process stuff, because it's not all Wild West out there. There is a whole bunch of people helping you. So the first thing is there are a couple of websites where what are called CVEs, common vulnerabilities and exposures, are recorded and tracked. Okay, and there's the URL, and you can do it. The primary thing is for us to have a label for the problem, so when we tell you about it, you know you can go find out more information about the problem, and you can see that that particular problem is fixed. Right? Okay, CVE, blah, blah, blah. It's in Eclipse OpenJ9, it's in Hotspot, it's in Azul, it's wherever. Yeah, they fixed it. Or it's not applicable. You've got something to put a handle on. Okay. And you can scan through this website for bugs or CVEs. So this is this morning. The lists are old, but the number's current. So I just went in and said, how many open CVEs with Java in it? It said 1761. Okay, that's not a problem because everything has bugs, and you can go to CVE and type Python, you name it, you'll get lists, right? The point is, there's the list. And if you pick them, if you look in details, you'll see words like this, right? One of the most obvious words you'll see will be things like unspecified, right? Okay, unspecified. And if you look at one in particular, for instance, here we go, unspecified vulnerability. We're not going to tell you anything about the contents of that vulnerability unless we really, really have to. Because what happens if I share publicly all the information about a particular vulnerability? Well, I'm giving it away. And the analogy is us sharing the details of how you could be hacked is the same as me tweeting my credit card and PIN number. Okay, I just give it away. Have my money. And that's why we're not going to tell you about the details. And in fact, we're going to try very hard to make sure that you have to work hard. You can go to the repos and you can do investigations, but you won't see a commit log that says CV blah, blah, blah. No. Okay, we're going to hide as much as possible for your own defense. Right. So what we are going to do is we are going to give you some hints as to whether or not this is useful or not. So there is this thing called the Cve Scoring System. Basically, we have a checklist, I'll show in a second, and they look through it and they go, what's the likelihood of this being used, the impact, etc. Right, okay. And one of the things that they also consider is time. These things change as information comes into the system. So we may go, oh, there's no exploit. It's complicated. But as soon as we figure out that somebody has figured out to exploit it, then the number will go up. So you can't just go and look at it once. You just have to keep coming back, okay? And we check against a whole bunch of things. So they have this thing called a vector. You can read the words. And they're the sorts of things you might think of about how do I assess what the impact, right? What is it going to hit? Is it going to hit my availability, my integrity, my confidentiality? All those things are marked, right? And then there is a big score, comes out at the end, okay, and we say, hey, this is probably the number one thing you need to fix, or it's not that important, okay? It all works on the basis that you are the ones who have, you're using your system correctly and you haven't given everybody root access and things like that. If you behave non-sensibly, then all bets are off, okay? So anyway, when we've got one of these things, we will tell you. Oracle publishes these advisories, we publish the same thing from an IBM point of view. You don't have to read them, but what you have to be aware of is the process of, there's an important part of this process, which is what happens when we go, hey, we've really got an important one. Okay. Now, if you find one, so if you find a piece of code and you go, oh, I think I could see how that could be exploited, okay, don't shout about it, don't tweet it, please don't sell it, report it nicely, don't turn up on /dot and say, hey, I've got found a vulnerability. Do it nicely. Even if you're not sure, just report it, okay? Don't worry about severity, just let us know, okay? And then, when you've reported it, or we found it, we're going to fix it. But of course, we're not going to fix it like that if it's a low priority stuff. We have resources to spend as well. So there's a whole planning thing based on this thing. But what it means is, to be aware of, is that if you see basically an out-of-bound release saying we have a vulnerability that's not part of the normal cadence, that means it's really critical. So you should go fix it. Okay. Right, so how would you decide whether you should fix it? Well, that's a problem on its own. So here's where it all starts to go a little bit wrong. You can go look at all this, you can go read all about CVEs, and they'll say to you things like, well, if it's a JAX-B problem and you don't use JAX-P, don't apply it, or whatever, okay? My advice to you is not to take that at face value, because basically, if you don't know what your code does, you're definitely don't know whether you should employ it. And because we're quite good at just adding dependencies, the chances are you have no idea whether the dependencies that you've got use JAX-P or whatever it is, right? Because you're not paying attention, you're probably not using the tools to help you understand that. Right. So let's talk, to round off, let's talk about some more of the words you'll hear and what that means. So attack vectors. That is the description of how they get in. So I'm going to run through those and then we'll do some more code. Okay. Right. But this is important. So the first one, the top of the list, the one thing that if you paid attention to and put more diligence in, problems would be much less. And that's validating your data. We are all very good at not validating data when it comes in. Okay? It's not just text. Okay? It's any data that you receive in any format, can be exploited. Okay? And what they do with that, the consequence to you depends on the vulnerability. Okay, so it might be that they upload images to you and you don't check, you don't put any constraints on the amount of data coming up. So you may say, oh, I'll take a 1 meg image, please, and somebody tries to shove a gigabyte up. If you don't stop that, your system goes down, okay? Or they try and hit you too many times, okay? But it's all about the fact that you're not validating the data that's coming in, okay? And when I talk about images, because that was on there, it's not, as I said, it's not just text. This is a really nice little exploit. It turns out in the JPEG code, right at the bottom in the C code, there was an exploit, a vulnerability that allowed arbitrary code to be executed. So it isn't a Java problem, right? But again, somebody figured out how to read the JPEG format and to insert into the JPEG format some code to be executed that you didn't see. Your nice little kitten gets uploaded, and as part of the parsing and turning it into a JPEG format in memory, this payload came through and got executed. Okay. But it's also text as well as images. So let me explain this one. The top box, okay, you can see it says content type and then a bunch of stuff. And at the bottom it says Apache struts. So that might give you a clue if you're paying attention. So Apache Struts, app server, says if I get a web request in and it says, and the content type field contains multi-part form data, okay, then that's what I've heard. If it says it's of this format, I will parse it. So what happens is Struts tries to parse all that GORP and it fails, which is what you'd expect. It says that's not in the right form. However, the failure, as part of the failure, what happens is, and this is the scary bit, is that code actually gets executed. Because Struts, as part of the failure, realizes that this is in fact a thing called OGNL, scripting language with Apache Struts, that gets executed. And if you look squint cleverly, you can see it says Java lang runtime at get runtime exec something. Okay, this is off the wire like the first problem we saw. No checking because it's content type. It gets executed. It gets executed because it was invalid. And there was some helpful code going on to say, I better give you some information about why things went wrong. Okay. Any idea who this might be? Famous thing in the press the last few months? Okay, there's this one, Equinox. That's the Equinox problem. And that URL at the top, you can go read the full details, right? Literally full details. Normally these things don't get disclosed. So that's what you get by being helpful. Right, so what else have we got on here? We've got things like untrusted code. Can I get you to run code? Okay. Don't worry about reading the words. Untrusted code is, can I get you to run code? Well, actually, I don't upload code to you. I find out code that you've already got on your system and I figure out how to call it. Okay. I have things like plug in a web start, with another great attack vector. The good news is that it's almost completely gone. We don't use applets to do graphics on the web, but there's still legacy stuff in there. I did a scan on CVE for an applet and it had 323, so it's quite a large number. There are weaknesses in our implementation, so like cryptographic things. There are ones where the actual protocol for creating the cryptographic environment is flawed, and you've heard about some of those in the press. They get nice names, and then there are bugs in the implementation where somebody did it wrong. They don't get nice names, okay? Right. And then there's attacking your local system. Can I get into your system? And okay, because if I can get into your system, then I can do whatever I want. Okay, all sorts of ways of injecting. If I can get it into your system. Okay, they don't normally have a high Cve score because the theory is that you can't get into your system. But let me show you, that's not really what you might think. So even your local system isn't secure. Okay, anybody know what this is? Anybody had this? Oh, cool, that's good. Okay, so this is WannaCry. This was this ransomware, okay, that had a payload mechanism that you can go buy on the dark web to get code onto your system. Your system is not as secure as you think because they can attack your personal machine, and your personal machine, if compromised, can get into your server. You would be surprised. WannaCry broke a lot of things. The horrible thing about WannaCry is that some journalists managed to get in contact anonymously with the guys who created this, and they said, oh, we made about $500 for every machine that we compromised, or whatever it was. They went, no, it wasn't that. What was it? Oh, yeah, they made $85,000, $3 per every machine. They brought down production lines, they brought down hospitals, Renault brought down the production systems, right? You think how much damage that caused, and these guys made minimal amount of money out of it. Okay, WannaCry got onto your system because of the payload delivery process. Your Java server is just as vulnerable. So more examples. Deserialization. Wow, I have lots of words there, but how many people here use serialization? Okay, how many of you are Java programmers? Okay, that's not the same. If you're a Java programmer, you may not realize it, but you're probably using serialization. You may be thinking of serialization as Java serialization, but actually, you know, it's basically any form. It could be traditional, it could be extreme, it could be images. There's all places where data gets converted into complex state within your Java objects. All of those are potentials for getting you to drive code. Right. And there are things like JDWP, this is a silly one, but this is just to bear in mind that if you use JDWP, the debug protocol, don't expose the ports on the public web because people will hack you, which is what happened to a large bank. If you can get into somebody's debug environment, then you have full access to their memory. Okay. Right, let's do some more code because talking about CVEs and things is a little bit boring, but I'm just trying to get you to think about it. So, this is going to explain to you another little bit about how helpful we can be to ourselves and how that can go wrong. So, some code. There's a properties object. It's backed by system.getProperties so that I can do -d, blah, blah, blah. It's one of those examples where you go, I've got some data coming in, and I need to get a handler for some data, and I'm going to do some handler to instantiate some class. You know, we all do that. We have some map. You know, it's an integer, it's a string, or it's something more complicated. I'm going to just instantiate a class that implements the code and call it, okay? So here we are, load class helpfully is going to do the loading of the class, okay? And you can see it's got a property, and if it doesn't like it, it's going to throw an exception. So the table at the top right has two entries in it. The first one, default, just a class name, another one called foo, because I couldn't think of anything else. Okay, so if I try this piece of code, it says class, load class helpfully default. That will translate into foo string handler and it will create the class. Okay, and there we are. It runs, and the nice little message tells me that I got a particular class. If I do it again and I put in foo, and this class doesn't exist on my class path, I get an error, and the error says blah 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 blah. Could not create class for, what does it say, for handler foo with value com.ibm.runtimes.demo.foo. Class didn't exist. I got a nice little error message out. Now, if I'd been a bad guy, I might have tried something like this, java.ext.ders. So when I run that, I get that. I get some dump in my extension directory. Okay, we'll just finish this off and then we'll talk about it. What happened there was I was being helpful to myself by making it backed by system.getProperties, but what I was actually doing was exposing all the contents to the end user. And if somebody can get into your data streams, which they can, then they can start probing you and asking you questions, and your system will respond. You know, user.home, you name it. Okay. So if I can do that, I can find out what's on your class path. I can find out what's on your extensions directories. I can find out what version of something you're running, and in which case I can figure out that you've got a vulnerability. So I can do that. I can get WannaCry and all those things to get code onto your systems. I can totally compromise you because you help me. So to wrap it up, you've got to add this. Developer aids that we will create ourselves get exploited as easily, if not more so, right? Because we're too helpful. We give information out. Okay, so I hope you're thinking about this, about what you've done and what you could do differently. Right? There are bad guys out there. They're out to get us. They are going to be looking for ways to exploit your code. And the more information you give them to help them, you know, they can say, thank you very much, give me your 600 euros. So what can you do about it? Well, you can improve your coding practices. You can go read, and most of this is about reading. CWE have a whole bunch of things that you can learn, patterns and anti-patterns of how to do it and how not to do it. Some are a bit trivial, but worth stating, like don't hard code passwords. Okay. They have these things called the 7 Pernicious Kingdoms, which is a taxonomy of these problems. Go read about those. Go see what people think about the different types of problem that you're not thinking about. Okay, you can go read about serialization. This is the Oracle secure coding guidelines. There's a whole bunch of things about what you should do with serialization, how you should deal with it. Okay, I've got another link for that in a second. The information is out there, but you're not using it, so it's time to go read. Go pick up the tools that are out there. This is just one I found at LGTM. You can connect it to your GitHub repo. This tool understands anti-patterns, and it will scan your code and it will tell you. You can go use other ones like Find Bugs, or this one case, the Security Bugs version, that will does the same thing. Got the code, go have a look. It will scan your code to help you. You can go look at all the online materials. You can look at Owen Wood's stuff, which will help you get your head around the risk assessments. Where do I put my efforts? How am I likely to be attacked? What should I do next? It's a big world. It's a big problem. These sort of things will help you bring it down. Lots of online guides will help you teach you, like OWASP will tell you, what are the top 10 ways that you're being attacked? Go have a look at those and figure out whether they apply to you, etc., etc. So, just the last few minutes, there are some basic stuff you can do. One of the things you've got to do that's unpalatable is think about updating your code, your dependencies, the versions all the time. People get very unhappy about the idea of having to apply fixes. But basically, if you don't apply fixes and somebody knows you've got an old version of something, you are at risk. Okay? Don't write all the custom stuff. Don't write your own security managers. Don't do your own trust managers. Don't write your own parsers. Make use of what the community is offering, because there's a lot more people focused on making it secure. Okay? If you want to reduce your risk serialization, this is a great link. Okay, it's an IBM website, but that's not the point. This guy wrote this in 2013. Serialization problems have been around for a long time. This guy will tell you how you can make your design of your software more robust without having to go through too many hoops. The information's out there. Okay, you've got to keep current. You've got to start thinking about separating the design of your system so that you can ensure that if somebody gets into some part, they don't get into all of it. You've got to think about the data that you're giving away and how much of that can be used against you. Now, we're doing things like microservices nowadays, which is beginning to do that sort of separation, which is really cool. Okay. You can't design code and be too helpful. I said that wrongly. If you are too helpful, if you're helpful in any way, it can be used against you. Be very clear about who benefits from the error messages. Right? It's like not having a custom 404 web page. After time, if you don't have one of those, you get a stack. If somebody can see the stack that you've got, they can work out what you're running. There are lots of tools out there to help you do that. Go look at penetration testing. Go read what the bad guys do and the good guys are doing to figure out how they get into your systems, etc. It's a really bad place at the moment. We're on the back foot. There are very many professional people out there trying to hack us. There are equally as many professional people trying to help us, but we're not paying attention. So I hope that when you leave here, you're going to go and do a bit more investigation. You're going to go read the stuff that's out there, and you're going to think a little bit more about how your application is designed and whether you should be thinking differently. That's it. Thank you. And apparently I have 1 minute, 9 seconds. Any questions? Oh, I was going to take a photo, see if you're all scared. I don't think you're scared. Oh, I forgot that. No questions? Oh, one here. Oh, I can't see you because I've got bright lights in my eyes. Yes.
Hello.
Hello.
So I have a couple of questions.
Yeah.
One is, for instance, about the legal liability of companies like IBM and Oracle. They're obviously offering these libraries with a GNU open source license.
Yeah.
Do they actually have zero liability if something happens? And or do you see this changing in the future? Given
That's a very good question.
The trolley problem and so on.
Who has liability? If it's just open source, then I think there is limited liability. Depending which part of the world you're in, there's less or more. If it's production, so if you've got a license, you've got a support contract. Whatever the support contract says. And the thing is that the processes that we use, others use to get fixes out to you, is the due diligence. So if we tell you you've got a problem and you don't fix it, then it's definitely your problem. Right?
I see. And does, for example, IBM use services like bug bounty, where they incentivize people to find bugs?
So I don't think we do that in Java. Do we do that? To be honest, if you ask people to find bugs in runtimes, almost never happens because it's a very complicated environment, and so people tend not to do that. Smaller things, yeah. So what can I say? I don't think we use bug bounty. Definitely not in the Java space. We might use it in other places. But again, it's like, even if you did, for runtimes, middleware and stuff like that, it probably wouldn't amount to much.
Depends on the bounty, I guess.
Yeah, but the trouble is, if it's too big, and we have lots of people submitting it, then you've got to go through them all and work out which are reasonable and stuff like that. So it's a difficult thing. Primarily, what we need is you guys to be going, I need to go read a bit more. I need to go think about the tooling I use in my DevOps processes. There's all this help out there. We're just not very well connected. Yeah. Okay. Thank you.